Yeah, thanks. So it's really an honor to open an event like this. I've been to a lot of conferences over the years, and Heapcon is always special. So I've been doing software supply chain security for the last couple of years, and part of that, one part of that is dependency management and trying to figure out what's inside our products and software and how vulnerable these things are. And then when you start digging through all these things, you peel like an onion, like one layer after another, one acronym after another. And I thought it would be a good thing to take one step back and go through all the basics and see where all this data is coming from and how they're managed and organized, right? So when somebody says software vulnerability, everybody thinks first about CV. So let's start with that. What's the CV? First of all, CV is a program. It's run by the Mitre Corporation, sponsored by the US government, which has its own complications that we will see in a minute. And basically, it consists of a number of organizations on the different levels, but the CNAs, the CV numbering authorities, are organizations that are allowed to assign and publish CVs. Red Hat is one of them. And the whole point of this program is to provide us with two things. So first thing is the CV ID. I'm sure most of the people here saw something like this. It's a CV-year-number. And the whole purpose of this is to give us a common identifier that we can all talk about, that we all talk about the same thing. Like super famous exploits like Log4Shell and SolarWinds, they get their own nicknames, but the CV IDs are for the rest of the vulnerabilities out there. And beyond the ID, there's a CV record, which we'll go through a little bit later on. So here's basically the flow of discovering and publishing, and a first step in the life cycle of the vulnerability, right? So somebody discover a vulnerability, it usually approach either the company or the open source team behind the product and disclose this in person. And this organization then reports this to one of the CNAs participating in the CV program and requests a particular CV to be assigned for this. And at this point, we have a CV ID, but nothing, it's only reserved. So nothing is published yet. The goal is always to try to come with a mitigation and a patch and the next release before actually publishing the data. And at this point, we are saying that this CV is embargoed in this scenario and should be kept to only people that need to know how to provide the initial fix. You will also often heard the term the zero-day vulnerability, and that's all the vulnerabilities that didn't actually come through this program. And these are vulnerabilities that are exploitable from 0 day, right? From day one. So once we have some kind of solution, the CV is published to the public. One thing to note is that this period between the reservation and the publishing can take a year or multiple years. So sometimes you might see like a CV 2022 and you think in 2025 it's an old news, but it's actually not. It's only been published for various reasons. So now we have an ID, we published it, the base record of the CV contains only a few details and on purpose. So it's a brief description of the vulnerability and the references to affected products and other security advisories that explains more about these vulnerabilities. So there's no any technical details or exploitability or mitigation information at this phase, right? And today, we have a nice thing called the CV List V5 project, which is basically a GitHub repository where the CV program submits and publishes all the all the vulnerabilities every day. And it's a very nice thing to do because it's a very transparent and version controlled way to publish this kind of data. It actually contains like a JSON schema where, yeah, it contains everything that we want to know about particular vulnerability in this at this stage. So first next step that's going on after this is something called NVD enrichment. NVD is another organization, National Vulnerability Database, where national is US national, right? And the goal here is to start adding some more context to the vulnerabilities. What we usually want to know how something is severe, right? How serious is the vulnerability? So trying to put some kind of score on it is a big thing, and we will talk about it much more. But also provide like a much more detailed and, so to say, machine-readable way to identify certain products and projects that are being affected at this point. So let's talk a little bit more about CVSS scoring. I have a lot of slides on this, but we will skip some of them through. So the CVSS scoring is again a standard developed in parallel with the CVE. And it's the idea to like put a number on a vulnerability to see if something is critical or it's low in a severity, right? So, and it's usually used by teams because security teams are usually dealing with lot of vulnerabilities on daily basis. So the goal is to prioritize things that needs to be fixed first and leave everything else for later. So how do we put a number on something like software vulnerability, right? So first of all, the standard evolved over time. So it was introduced sometime in the early 2000s, but only since version 2 it's been widely adopted. Today is mostly version 3 and 3.1 are used, and in recent years version 4 is you can see it more and more being added to the vulnerabilities. And the idea with every new version and every revision of this is to improve how we do this scoring and to be more precise, to be able to better explain with a number of what's going on in the vulnerability. And usually you can see multiple scores, multiple versions of the scores, as we will see in the example later on, in one single vulnerability, showing like how this would be scored by version 2 or version 4. And in that case, usual advice is to go with the latest version because it should be more precise in describing the vulnerability. The old scoring stays there for legacy reasons and legacy tools that depend still on the old versions. So how this basically works. So the basic idea is to define certain metrics for the vulnerability, the base metrics, the things that are defining it, then some temporal metrics that shows us how this vulnerability changes over time, and some environmental metrics that explains how this have impact in specific environments. For example, for the base metrics, you can have something like attack vector. So like it's completely different if your vulnerability can be exploited over network or if somebody needs a physical access to the hardware to do something. Also, if something is very complex to exploit or very low, does it need to have a particular user interaction? Does it have to have administrative privileges to execute something? Those all things define the severity. And basically what's done is that, every of these things have some kind of the coefficient attached to them, and there's like a basic math that put this together into a score. So it's a little bit below, but usually when you see CVSS scoring, you see that unreadable string that basically tries to sum up all of this in a parsable string, and that using the calculator produces the score of 5.9, which basically means this is the medium severity CV. This is just a visual representation of all this. And if you have more interest about all this, there's a very good examples at the first organization site that you can see how they propose to score different things, and you can play with the calculator as well to see how changing the different metrics affects the score. As everything that humans do, there's always shortcomings, and somebody says it can be done better. That's why we have things. So the version 4 is the latest version, trying to improve the math and provide some more granularity there. But also, like, all these things and the whole CV program comes from the so to say, old IT world, where we were interested mostly in securing operating systems and a couple of applications. So version 4 gets more interesting into like hardware and IoT systems, providing metrics for like safety and recovery of those systems. So this is one of the examples from the first site that I said, and here you can nicely see how things change when you look at the different versions of the scoring. So it's 8.1 with version 3, it's 7.7 with version 4, only using the basic metrics. But if you add additional threat metrics to it, it even goes lower. So yeah, you should always try to take the best possible and the most detailed metric that you can find. So that's one part of the story. So one part of the story is how serious is something, and the other part is what exactly is being affected. And that's where we're coming to the topic of identifying software components. And it's like a huge can of worms, and it requires its own session, because all the people have different opinions how we should do that. But here we will stick to two most common specifications that are being used in this area. One is the CPE, and other is the PEARLS. So CPE, coming from the Common Platform Enumeration, it's something that actually also evolved with the CVE program, and it again provides us like a very simple format that we can define basic things about software products, like a type of the product. Is it operating system or the application? Which vendor is producing it? Which version it is? And then maybe some additional qualifiers. But even seeing this, you can see that it's coming from like a pre-GitHub era, where there was much less open source there, so we were focusing on operating systems and things like that. So these are a couple of examples, like Red Hat Enterprise Linux 8.4 and one specific version, the server in the beta version. You can see here that it can still be used to identify open source packages like Apache HTTP server, but it's far from the ideal. Today it's still used. It's more used to define the products as wholes. There's also like a nice dictionary that you can go and see about all commonly used software products, commercial software products. That are out there and that are being mentioned in the CV world. But as I said, like being for the last 10 or more years, open source exploded, and that's a good thing. So we have much more dependencies, much more libraries, and we need much more flexible way to identify them and address them all. So the package URL effort is that. It's an effort to create like a HTTP like a schema, and to be able to identify open source packages from basically any ecosystem out there. So you can see here different examples of Docker containers or Maven jars or you know, RPMs. It's a simple schema, so ecosystem, namespace, name, and a version, and then, you know, unlimited number of qualifiers that can additionally help us to tie things down to like a specific architecture or something like that. So now we need to put these things like in a container, and that's where software bills of materials are coming into play. We talked about SBOMs, I think 2 years ago at Heapcon, and it's a big thing in all the software supply chain security. I like to, you know, compare it with like a food declaration. So it's a list of all the things that it's in your software project or a software product. And today those things can go in hundreds or even, yeah, tens of thousands of libraries in a big product. Because we are technical people, we want to have it in a machine readable way, so it's usually a JSON file, and it allows us to enumerate all the things in the product. And how it's used today, a lot of the times, so it's not always, but mostly people are using CPEs to identify the whole products and then use the pearls to identify all the open source packages and components of the product inside of it. Okay, so let's wrap up with CVE. So if you tracked the tech news earlier this year, so all this thing, there was a huge problem with the plans to cut the funding for the CVE program that got averted in the end, but it put a lot of people on uneasy mode. So there are a couple of efforts to do this in another way, so in more decentralized way, and then different regions like EU started to have their own independent program for their own purposes. I personally also didn't dig too much into this. I know they exist, but they're still not that widely adopted. So I think the CV is, for better or worse, here to stay for a foreseeable future, and we should depend on it. So that's vulnerability. Now we're going to security advisories. So what's the difference? It's the first question, right? So we said that the original vulnerability doesn't have too much details into it, right? And then we have a common identifier, we have a basic description, and then everybody is adding their own opinions about this vulnerability. I would call like this NVD enrichment process also not part of the vulnerability, but this is like a first low-level security advisory, because this is what NVD thinks about this vulnerability. So security advisory is adding a lot more context. So they would try to add much more details about what's affected, maybe not on a product level, maybe on a component level inside of the product, but also try to then add this more remediation information. Is it update that's available? Is it a hot fix? Is there some mitigation technique with changing configuration detail that would fix this particular vulnerability? That are all coming from different organizations talking about vulnerability described by a certain ID. And the thing is that, yeah, one security advisory can cover multiple vulnerabilities in a global way. And traditionally, in the first period, these were like super informal, like people were producing reports, PDFs, or HTML pages about all this. But yeah, lately on, we are starting to see more standards and more acronyms that are done to do so. So one of the initiatives that's very popular today, and for a good reason, is the OSV, Open Source Vulnerability Initiative, started by Google. And the whole idea is not to provide alternative to CV, but to provide a more complementary thing that we can address better open source vulnerability with this. Because, as we said, like CVs are historically more focused on commercial products, and we would like to better support security advisories about particular open source projects, libraries, and things that people are using every day. So it can use CVs to talk about CVs, but it can also provide a way to support non-CV identifiers for specific purposes. So there are two parts of the OSV project. One is the OSV schema. It's, again, all this world is just one JSON schema after another. So it's another JSON schema to help us describe vulnerabilities. And this schema can be used, so today, for example, is used by the GitHub Security Advisory Database to publish all the things that they found for different CVs. And for example, RustSec is also using this to publish Rust language related advisories. What it basically gives us is a little more granularity. It accepted Perls as a way to do this, to identify the components. So it's much easier to live with. One good thing also for the OSV is the OSV.dev service, also run and hosted by Google, where they try to aggregate all these different OSV sources and provide a nice API and service that you can query and figure things out. So try to find the vulnerabilities in libraries that you are interested in. So, another slide, another acronym. So, VEX. We thought about security advisories, and says that security advisories are explaining one or more vulnerability and adding a little bit more context to it. But it doesn't talk in the context of a certain software project or a software product. It talks about vulnerability in general. So what's the idea behind the VEX is to actually add a more context to a security advisory, to basically talk about advisory in a context of a certain product. So it's usually a document that accompanies the SBOM, because SBOM defining the product version, and then having VEX saying, okay, in this SBOM, in this product, we have these vulnerabilities. And what's important is that it adds a little bit more information, because a certain product, if you only look by its component, it can have reported a certain vulnerability against that component. But maybe that thing is not exploitable in your product, because you're not using the certain feature, you're not configuring it in certain way. So this is also a way for security teams to basically advertise the state of their product based on their vulnerability analysis. So basically, this is what would people use, what you would use to send information to your users or customers about security issues. So, for example, when the next Log4j comes, and it will come, people will ask, okay, are we affected? And this is like a structured way to do this. And also, the vulnerability exchange documents can also have their own lifetime, and they can change over time. So basically, you can first issue something saying, okay, we are investigating this, and then, okay, we know that we are affected, and then, it's fixed, and this is the mitigation of this particular vulnerability. And the whole point is to try to put a little bit more order in the sea of information that are coming from different vulnerability databases and apply that to a certain product. Today, so we say that usually, VEXs are tied to SBOMs, and today the two most popular SBOM formats like CycloneDX and SPDX support to basically, embed VEX statements directly in the SBOMs. But there are also certain formats that are used only for this. I said that OSV is one of the formats for security advisories. CSAF is the other one. It's much larger and more complex and older. But CSAF also have a specific profile that allows us to actually publish VEX information as well. And there's also a new effort called OpenVEX, which tries to focus only on standard for releasing VEX information in a much simpler way. And for the reference, here's the link where Red Hat basically publishes all its own security data, still using mostly the CSAF document, but I think starting this year, they're also publishing everything in the OSV format as well. So now coming to a project that I'm working on, and basically it's trying to make sense of all these things together, right? So we have a lot of sources of data. We have different SBOM repositories where we get information about the products. We have CVs, we have OSVs files from different sources, CSV files, and all those things by their own doesn't. It's a lot of data and no useful information. So the whole goal of GWAC and the Trustify projects that I will talk a little bit about here is to, first of all, collect all this data, parse it, store it locally, and try to provide the correlation logic to be able to try to link these together. So certain vulnerabilities to certain products and components inside of it. So that's in the a most compact way it can be described. It basically provides a user interface and the CLI based on it, that it can be used to then query this data. GWAC originally envisioned itself like a graph, because this is basically a graph problem, because everything is connected to something, and being able to try and search all this information is super useful for the product security teams. The usual first question is, how does this compare to like a traditional scanners and things like that, because people were using that for decades. And the whole idea in the software supply chain security thing is to shift things left. So to be able to find these things as early in the development process as possible, right? So not only to scan our runtime code and things like that, but being able to flag untrusted or vulnerable dependency directly in the IDEs, or fail the build process if we detect that there's a critical vulnerability inside of it. It's all part of the process to make our software much more secure. So beyond just advisories, there are a lot of other software supply chain security metadata that are useful to people. Licenses is one of the perfect examples because for compliance reasons, some companies don't want to use packages of certain licenses. Those information is also very often contained in SBOMs, so that you can easily search all your dependencies and try to find the ones that are not compliant with your policies. So I don't know how much time we have. Actually, I know. So this is just an example of the UI. Maybe we can do a quick demo for a few minutes. Today, we use Trustify internally in Red Hat by our own product security team. And there's last time, but this is also the old information. There's 60,000 SBOMs at the moment stored in there. Because everything that's being built lately is going directly into the database. There's a much more features that needs to be done. So I mentioned licenses that's now released, but also introducing a product, a concept of the software product as a first-class citizen is something we want to do, because we are now talking mostly about SBOMs and defining things as SBOMs, but usually people want to take care of and think about their products and see how things change for the product between the versions and compare is something more vulnerable or not over time. One more big part of the whole software supply chain securities are signatures. So signing everything, starting from Git commits to the final artifacts and using the SIG store in the process is a big thing. So storing the signatures and being able to confirm that all the packages inside are properly signed and trusted is also coming. And we also, coming into the new era of AI and more and more our software products will not be only the libraries but different models. So that's where the concept of the AI bomb come to place, and trying to secure the whole AI chain is becoming important, from signing the models to being able to properly define models inside is also something very important. And we also provide an MCP server because everybody does, but we will figure out how we're gonna use it later on. So there's a lot of challenges here, and just a couple of things to mention is that all the specifications that we talked about are very general and loose, and for a good reason. And that means that different people use it in different way. And there's a lot of data quality issues there. So it's very hard to actually do this correlation in a very specific way. So it's a work in progress, but we are getting there. But also one of the interesting things about all this domain is basically that we are living in a multi-truth world. So as you said, advisory is just opinion, and we get a lot of opinions, and they're sometimes contradicting. So the main thing that also we need to focus about in the future is how to present all this information to the user and let him choose his own truth in the end, right? And just talking about Trustify, we are coming to the point that we need to do a next scalability push and support much more data coming to the system. But that's coming. Last of all, so this is all done within the OpenSSF Foundation, the Open Source Security Foundation. It's a part of the Linux Foundation, and it's a community where all this work is being done. So GUAC and Trustify projects are part of that. I think also OSV schema is a part of the OpenSSF, the SIG store, the signing thing. So if you're interested at all in this topic, this is the good place to go. There's a lot of good materials, a lot of working groups, like AI/ML security working group, and it's a good place to start and dig into this area. So I don't have time for a demo, but I'll be here all day. I love to talk about all these things. So anybody want to talk about the vulnerabilities or supply chain security in general, reach out and yeah, let's chat. Thanks.